Hello and welcome. So, why don't you read this problem? It might seem like a silly place to start today, but everything will make sense in time. So pause it, give it a try, and see what you get to. The answer is that you can make 9 bikes. Okay? So if I look through here, the first thing that I see is that I need to balance this equation. Okay? So this is for a tricycle, right? So a tricycle has a frame, some handlebars, 3 wheels, because it's a tricycle, a seat, and 2 pedals. Okay, so now I need to go back and I need to balance, and I don't need this, I can balance this equation. All right, so I need 3 wheels and 2 pedals. Okay, now I can kind of look through here and I can see how many tricycles I can make with each of these. So I have 10 frames, which means that I can make 10 tricycles. I have 12 handlebars, so I can make 12 tricycles, which means that I still only have enough frames to make 10. So I can make 10. I can still only make 10. 29 wheels. Okay, I would need 30 wheels to make 10. I can only make 9 tricycles with the wheels that I have. 24 seats, so I can make 24, so I can still only make 9. And 37 pedals, I only need, 18, so I have more than enough. Okay? So, in this case, we say that the wheel is what's called the limiting reactant. Okay? The number of wheels that you have limits the number of tricycles that you can make. So that name kind of makes sense. And then we say that all the other reactants are, quote, in excess. So you remember we saw that word the other day. Now we kind of know what it means. Some things limit, and some things you have more than you need. Okay? So let me ask you a question here. How many frames are going to be left over? Okay, well, in order to answer this, because I want to be able to generalize this, because you will be asked to do this a lot, what pieces of information do I need? So I want you to pause and think about that for a second, okay? And once you've thought hard, you might come to the fact that you need to know how many frames you started with, how many frames you started, or you could say at the start, okay? And then you also need to know how many frames are used. Okay, and if you subtract those, you'll get how many are left over. Okay, so in this case, we'd say we started with 10 frames. Okay, we're going to use 9, right? And that means we're going to have 1 left over. Okay, so the reason that I start with this very concrete example is to show you that you have an understanding of what's going on here. Like, you can do this. You know what's going on. So when we take this and we apply it to chemistry, all we're going to ask is, don't freak out. You know what's going on, okay? So here's a typical problem, okay? This one's pretty easy. So one thing that I'll give you a couple pieces of advice here, okay? Read through this, and once you have, okay, you'll see that you're given information about both of the reactants, okay? If you're given information about both reactants, that's an indicator that you're doing a limiting reactant problem. Okay, and this is a very typical layout for the limiting reactant problem, as much as I don't love this. Okay, so you'll be asked which reactant is limiting, and then you'll be asked how much H2O can be formed. Okay, so H2O is your product. So this question B, we're going to use answering question B in order to find question A. All right, so how much H2O can be formed? Well, it doesn't specify what we're looking for, so why not do the easiest thing, which is moles, right? So I want to know how many moles can be made from water, or how many moles of water can be made. If I start with this 10 molecules, oh, and this is 10 moles. I'm simplifying that to 10 moles. Okay. 10 moles of H2. Okay. Now, the key thing here is I don't just have hydrogen. I also have oxygen. So I need to set up the same thing, but with oxygen, 6 moles O2. Okay? Now I can see that it's a pretty simple conversion, all right? I'm converting moles of H2 into moles of H2O. Oddly enough, the equation is already balanced, which is really nice. So I can do moles of H2 down here, and I can do moles of H2O up top. Okay? I go to the balanced equation. I know that there are 2 moles of H2 for 2 moles of H2O, which is really just 1 to 1. So I know that I could make 10 moles H2. H2O, sorry. Moles H2 cancel out. Okay, 10 moles H2O. And I'll do the same thing down here with the oxygen. Okay, moles O2, and I can go straight to moles of H2O using mole ratio. Okay, 1 mole O2 to 2 moles H2O. Okay, so I can make 12 moles of water here. Okay, now if I go back to the bicycle problem, okay, you could see that, let's take frames for example. With frames, I could make 10 tricycles. With wheels, I could only make 9 tricycles. Okay, so the wheels limit. So here is I only have enough hydrogen to make 10 moles of water. I have enough oxygen to make 12 moles of water, but I don't have enough hydrogen to make that. So this is how much water I'm going to make, which means that hydrogen limits the reaction. All right. So now I can go back in and say hydrogen's my limiter. Here's my B. Okay. And now, as promised, how much of each reactant and product is present in the mixture at the end of the reaction? Okay, well, a couple of these should be really obvious. So let's start with the obvious ones, okay? How much water are we going to have at the end? Well, if you do this reaction, you're going to end up with 10 moles H2O. Okay? And if I think really carefully about this, the hydrogen I also know. Okay? I start with 10 moles of hydrogen, but the hydrogen is what limits the formation of the product. Okay? So when you run out of hydrogen, you're going to stop producing product, which means that you should run out of your limiting reactant. Okay? So the only one that's a little bit tricky here is the oxygen, right? That's what we're trying to find in C. Okay? So I need to know how many moles. So in order to find this, I need to know moles of oxygen that I had. Okay? I need to know, and I need to subtract that from the moles of oxygen that I used. And that should give me the moles, or the moles of oxygen that are left over. Okay? So the had, I have. I know that I have 6 moles of oxygen at the beginning. Okay? So now I need to figure out how many moles of oxygen are used during the reaction. Now, if you think about that, okay, let me write that out. How many moles O2 are used when 10 moles H2 react? Okay? Now, I write it like this, and immediately you see that this is a dimensional analysis problem. Okay? So, right underneath that, I'm just going to set up my dimensional analysis. Question mark, that's 10, right? Question mark moles O2 equals 10 moles H2. Okay, and I can set up my stoichiometry. Moles H2, moles O2. Okay, and I can go back up to the top. There are 2 moles of hydrogen for every 1 mole oxygen. 2 moles hydrogen for every 1 mole of oxygen. So that means that I'm going to use 5 moles of oxygen. Okay, so I had 6 moles of oxygen. I used 5 moles during the reaction. So I'm left with 1 mole. Okay? So here's my answer. 1 mole oxygen remains. Okay? Now, I know that this is a long problem, right? These problems take a long time. That's okay. Go slow, go step by step. Make sure that you do everything stepwise and correctly. Okay?